Hello. We are on 1.02 geometry notes today, and we're going to be talking about angles today. So last class we talked about segments. Today we're going to be talking about angles. And you guys will be having a pretty short quiz coming up next class, and it will cover 1.01 and 1.02. So the segment notes and the angles notes as well. All right, number one, just talking about naming an angle. So I'm going to draw out an angle, and I want you to name that angle in 4 different ways. So the angle is made up of 2 rays. So remember, a ray starts at a point and then goes on forever in one direction. I'm going to call this T. So this is ray BT and ray BQ. I'm also going to put a number 1 in here. So one way we could name this angle is by using the number. So we could call it just angle 1. Another way we can name this angle is by using the letters. But it's very important that when you name the letters, your middle letter is always the vertex. So the vertex is the where the 2 rays meet of the angle. So TBQ tells us that B, the middle letter, is our vertex of the angle. We could go the other direction as well and call it angle QBT. And in this particular case, we could also call this just angle B, but that only works if there's only one angle at B. So let me give you another scenario here. If I draw the same thing that I have right there, slightly different. I just put the line down a little bit, but this time I extend another ray out. Let's call it R. Now, this angle is still angle 1, but I cannot call any of these angles angle B because there's this angle that has a vertex of B. There's this angle that has a vertex of B. And there's also this big angle TBR that also has a vertex of B. So there's actually 3 different angles that all have vertex B. If you call it B, we don't know which of those you're talking about. You can't just say, oh, it's always going to be the biggest one. It doesn't work like that. So the only time you're allowed to use one letter is if you have just one single angle coming out of that vertex. If you are ever in doubt, just name it with 3 letters. And you're also, with angles, allowed to write in numbers if they're not already there. So I could write in the number 2 here for angle QBR, and that's okay. What I can't do is we don't put numbers if there's more than one angle. So you can't call that angle 3. You can only name the smaller angles with numbers. All right. Let's also talk about just general terminology with angles. So some angle terms that you should all know. You should know what a right angle is. So hopefully in your head you're thinking 90 degrees. You should know an acute angle. An acute angle is less than 90 degrees. You should know an obtuse angle. Think obtuse, bigger than 90 degrees. Acute is like a cute little angle, so it's smaller than 90. You could have a straight angle, which is equal to 180 degrees. You could have a reflex angle, which is greater than 180 degrees. You could have supplementary angles. Supplementary angles means that the angles add to 180 degrees. One way that somebody showed me once to help you remember that supplementary is 180, think about making your S into an 8 and the U kind of into a 0. And then you just put a 1 in front. So 180 you can kind of make out of those beginning letters. And then complementary means that the angles would add to 90 degrees. That one is even cooler. You can make the C into a 9 and you already have the 0. So that makes it 90 degrees if you need a way to help you remember how many degrees the angles will add to if they're complementary and how many degrees they add to if they're supplementary. And the last one that we're going to talk about here is just adjacent angles. So adjacent angles just mean that they're next to each other. Adjacent means next to. Okay, let's do an example. I'm going to give you a diagram, and I want you to tell me what you can conclude from the diagram and the markings that I put on it. Okay, so, and assuming all these lines are straight, I don't have a ruler that I can use on here. So these are all straight lines. And this one right here, they're all passing through this point. And I'm going to call this 1, 2, and 3. I'm going to mark this one like that. And this will be 4 and 5. And I'm going to mark these two like this. So hopefully you're starting to think about and remember what those symbols mean. So this little box right here, that tells us that it's a right angle. So I know that angle 1 is a right angle. Then what we just talked about, we also know then that it's also the measure of angle 1. So usually when we use an equal sign, you want an M in front of your angle. So the measure of angle 1 equals 90 degrees because right angles are 90 degrees. These little arc marks right here on the 2 and 3, those tell us that the angles are congruent to each other or equal to each other. If you have more than one pair of angles you want to mark congruent in a picture, you would just add another line. So you could do them both as 2 arc marks. So we've got angle 2 congruent to angle 3. We also know that if angle 1 is a right angle, and we know that these 2 lines then are perpendicular because they're forming right angles, that means this side must also be a right angle. So if that's the case, then we know that angle 2 and 3 must add to 90, which means they're complementary. So I could write angle 2 as complementary. I'm just abbreviating to angle 3. I could see here that I have some vertical angles. So remember, vertical angles are the ones that make an X. So in purple, I'm tracing the 2 lines that are crossing right here. And hopefully by tracing, and it's really helpful in geometry to trace things, draw them, use colors if you have them. You can see the X that forms and the angles that are inside of that X across from each other. Those are called vertical angles. And so vertical angles are always congruent to each other. And we also know that any set of angles that forms a straight line will add to 180, so it's supplementary. So we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will all add to 180 degrees. Do you guys see any other angles that form a straight line? And hopefully you're looking at 4 and 5. So I know measure of angle 4 plus the measure of angle 5 equals 180. And in that case, then I know that angle 4 is supplementary to angle 5 because together they add to 180 degrees. So just some conclusions. I wanted to draw your attention to the markings like a box to show right angles, the arc marks to show congruency, and always be looking for those linear pairs and complementary angles. Number 4, the measure of angle ABC equals 85 degrees. Find the measure of angle ABD, and I'm going to give you a diagram. So our vertex angle right there. This is C, B, A, D. I'm also going to give you that measure of angle ABD is 2x plus 5. And the measure of angle DBC is 3x plus 10. So there's no markings here. I don't know that these ABD and angle DBC are congruent. I'm not told that BD is bisecting it. So the only thing I can do is first I'm going to mark this picture. So this whole thing is 85 degrees. I know that if I add these two together, that they give me the whole thing. And I know the whole angle is 85. So we call that the angle addition postulate. where you have the sum of the parts equals the whole. So we talked about that with segments as well, and that was called the segment addition postulate. So we're going to take 2x plus 5 plus, so that's this angle right here, plus our other angle, which is 3x plus 10, and set it equal to our whole, which is 85. And now it's just a matter of combining our like terms and solving for x. And then, of course, you can check that on your calculator. You can check the original, left side y1, right side y2, and always make sure that you've answered the question. So it didn't ask me to find x, it asked me to find the measure of angle ABD. So now that I found x, I want to substitute back in. So that would be 2 times 14 plus 5, which would give us 28 plus 5, which is 33 degrees. For your final answer. So that's angle addition postulate. Sum of the parts equals the whole. Next one, we're given that angle XOA, where ray OR bisects angle XOA. And of course, very helpful always in geometry to draw a picture. So we're given angle XOA. So the middle letters always are vertex. So the X and the A, it really doesn't matter which sides we put those on. OR bisects that angle. So O, it starts at O and it goes up. Oh, sorry about that. Not very straight. There it goes to R. So it says it bisects it. So since we know that it's bisecting it, that means it's going right through the center of the angle, which tells us we have two congruent angles on either side. An angle bisector divides an angle into two congruent or equal parts. So first question is, what can you conclude? Well, we can conclude that angle XOR is congruent to angle ROA. Why can we conclude that? Well, because definition of an angle bisector, which states that an angle bisector splits an angle into two equal or congruent parts, or two angles. Next, part B. If the measure of angle XOR equals 6x squared and the measure of angle ROA equals 17x minus 7, find all possible values for x. So if we go up here and we label this XOR, so I find X, then O, then R, that's 6x squared. Then I find R, then O, then A, and that's 17x minus 7. So we marked our picture here to show that these two angles are congruent, which means they're also equal. So I can set 6x squared equal to 17x minus 17. Now I have an x squared. Anytime I have an x squared and an x, I want to get that equal to 0. And solve. Remember, x squared, you always want to have positive. So it's already a positive 6x squared. So we want to subtract this side over to here, to the left side, getting us 6x squared minus 17x plus 7. No GCF out of these, and I noticed that the lead coefficient is bigger than 1, which means I want to use P's and C's. So first I'm going to rewrite this as 4 terms. Here's a quick refresher on your P's and C's. And my P is the product of my first and last term, so 6 times 7 gives me a positive 42. C is my center term, so negative 17. If I need help, I can go to my calculator and type in 42 divided by x to take a look at my factors. that multiply to 42, and I'd want to figure out which of those would add to a negative 17, and that's going to be negative 3, negative 14. So I'm going to put those into my slots, group the first two, group the last two, factor out my GCF. So the first set, I'm going to factor out a 3x, leaving me with 2x minus 1. Because remember, if you're dividing by 3x, something divided by itself is 1. It doesn't go away. The second set, the first term is negative, so you need to take out a negative number. The GCF of 14 and 7 is negative 7. So we're dividing each of these by negative 7, leaving us with positive 2x minus 1. Good news, our sets in the parentheses are exactly the same, so I factor that out, and it's 2x minus 1 times the quantity of our leftovers, which is 3x minus 7. Since this is equal to 0, I want to solve, so I'm going to draw my line, set each factor equal to 0. Extremely important that you actually write that step that I just did, that I set each factor equal to 0, and then solve. So we'd get 3x equals 7, divide by 3, x is 7/3. Here I'm going to add over the 1, divide by 2, and I get 1/2. Now with this one, it's really important. We're not just doing P's and C's, we're applying it to a problem. So you need to check that both of those work. So since they're both representing angles, you want them when you sub in x to give you positive values. It doesn't matter how small, because you can have really small angles, but you don't want to have negative angles. So take a moment here, pause the video, and check those into your calculator. So just type them in for x, make sure the two angles are still equal when you substitute them in, and make sure you get positives for both of them. All right, and hopefully you found now that those both check. And you want to make sure, again, that you have positive angles when you substitute them in. So you're subbing them in for those original expressions. All right, so 2 answers there. Next, number 6. We have if ray MA bisects, so again, we're bisecting angle CMG, and the measure of angle CMA is 4x squared minus 5x plus 30. Find the measure of angle CMG. So here's your picture. We've got G, M, C, and we'll put A over here. So we know MA bisects it. So again, really important in geometry to mark your picture. So if I know that MA is bisecting, it splits it into 2 equal parts. So I mark those 2 angles congruent. Now I know that CMA, so this angle right here, is the expression that they gave here, 4x squared minus 5x plus 30. I want to find CMG. So if this one is 4x squared minus 5x plus 30, and these two are equal to each other, then I can just add that to itself or just multiply it by 2, and that will give me my full angle. So I'm going to distribute my 2 in, getting 8x squared minus 10x plus 60, and that's going to give me the measure of angle CMG. And that's it for that one. So a little bit shorter for number 6. Number 7, given 2 supplementary angles, the measure of one angle is 6 more than twice the measure of the other. Find the measure of the larger angle. So let's start off by writing this out. So the supplementary, first of all, we've got supplementary means they're going to add to 180 degrees. The measure of one angle is 6 more than twice the measure of the other angle. So think about 6 more than twice. Is that angle going to be bigger or smaller than that other angle? Well, if you're 6 more than twice, it's going to be bigger. So we want to let x equal the first angle, which is going to be your smaller angle. So we know that one angle is x, the other angle is 6 more than, so addition, twice the measure of the other. So 6 more than 2 times the smaller angle. If I take this angle and add it to my smaller angle, those are supplementary, so that's going to give me 180 degrees. So that's the hard part of this one, is just kind of translating it, and then you're just going to combine your like terms and solve for x. So we've got 3x equals 174. Divide both sides by 3, giving me 58. Again, check to see what the question's asking. It didn't just say find x, it said find the larger angle. So x would actually be your smaller angle. To find the larger one, which was 6 plus 2x, I'm going to substitute in that 58. And that gives me 122 degrees. Okay, and that's the larger one. And the last problem we're going to do here for this lesson, number 8, doesn't want to scroll correctly. All right, there we go. Number 8, find x. This one I'm just going to give you a diagram. Here's a straight line. There's a ray. And this side is 4x plus 10. Hopefully pretty straightforward. That's 3x minus 5. So the difference here is I didn't tell you that this was bisecting these line. This is a straight line right here. And I didn't tell you the total of how many adds to, but this is one that you should be able to figure out without being given that information, something you can pull directly from the picture. You guys know how many degrees are in this. This is a straight line. How many degrees are in a straight line? That's right, 180 degrees. So you're going to still use your angle addition postulate and take your 4x plus 10, add it to 3x minus 5, and set it equal to 180 degrees. At this point, solve, combine your like terms, and you should get 25 for your value of x. And that is it for our lesson 1.02 on angles. If you have any questions, please let me know. And pi out.